Okay, so I'm going to make a video today on the combined gas laws worksheet. So let's just start with the basic idea that the combined gas law is that P1V1 over T1 equals P2V2 all over T2, right? It's a combination of Boyle's law, which is really sort of this part right here, Charles's law, which is sort of this part right here, and it also combines Gay-Lussac's law, which is this part right here. So like all three of them together really make up the combined gas law, and that's where it gets its name from, the combined gas law. So anyways, let's start. Number one, if I initially have a gas at a pressure of 12 atm, a volume of 23 liters, and a temperature of 200 Kelvin, and then I raise the pressure to 14 atms, and increase the temperature to 300 Kelvin, what's the new volume of the gas? So there's a lot of variables in there. So the best thing to do is just to start keeping track of them this way. So we got P1, V1, T1, and so we're really keeping track of them this way. All right, the initial pressure was 12 atms. The initial volume was 23 liters. The initial temperature is 200 Kelvin. That's already in Kelvin, so I don't have to convert it. The initial pressure, the final pressure is 14. The final temperature is 300, and we're looking for the new volume, right? That's the thing that we're looking for. So now we can sort of put these pieces together, and let's figure this out. So remember that P1V1 over T1 equals P2V2 all over T2. So when I plug in my numbers, it's going to be 12 times 23 all over 200, and that's going to equal 14 times V2, which is what we don't know, divided by 300, right? So now it's just pure algebra. Got to solve for V2. So it's going to be 12 times 23 times 300 all over 200 times 14. That is V2. And now it's calculator time. So 12 times 23 times 300 divided by parentheses 200 times 14 end parentheses. And I get 29.57. So 29.57. Now this is a volume, so this has got to be liters. Okay. So the new volume would be 29.57 liters. And it makes sense. It's going to increase in volume because you have an increased pressure and you also have an increased temperature. So it makes total sense you'd have a higher volume. Okay. Let's jump down to number two. A gas takes up a volume of 17 liters, has a pressure of 2.3 atm and a temperature of 299 Kelvin. If you raise the temperature to 350, lower the pressure to 1.5, what is the new volume of the gas? So notice that you're raising the temperature to 350, so that would maybe increase the volume, but you're lowering the pressure to 1.5, so that would decrease the volume. So we really have no idea what this is going to turn out to be. So let's just get started. Our P1, V1, T1, our P2, V2, T2. Our initial volume was 17 liters. Initial pressure is 2.3 atms. The initial temperature is 299 degrees Kelvin. The final pressure is 1.5 atms. The final volume is unknown. So it looks like we're looking for a volume again. Our final temperature is 350. Okay, so now let's plug them in. Remember, it's P1V1 all over T1 equals P2V2 over T2. Now I just plug in my numbers. P1 was 2.3 times 17 divided by 299. P2 is 1.5. We don't know what V2 is, so let's just leave that as a variable. The final temperature is 350. Okay, now it's algebra time. So this is going to I'm going to multiply both sides by 350. That's going to bring that up there. This one, I'm going to divide both sides by 1.5. That's going to bring that down there. And so it's going to look like 2.3 times 17 times 350 all over 299 times 1.5. And that's going to be equal to V2. So calculator time, 2.3 times 17 times 350 divided by parentheses 299 times 1.5. and I get 30.51. 30.51. It's a volume, so it's in liters. So it looks like it went from 17 to 30, so it almost doubled in size. All right, we're going to do just one more. Let's do, oh, here's one. Let's do number 6. I noticed because it's looking for an initial thing, so let's try it. Let's see if it makes anything different. So here we go. I have an unknown volume of gas at a pressure of 0.5 atms and a temperature of 325 degrees Kelvin. If I raise the pressure to 1.2 atms, decrease the temperature to 320 degrees Kelvin, and measure the final volume to be 48, what was the initial volume of the gas? So P1, oops, sorry, let's just do, sorry about that. So P1, V1, and T1, and then we've got P2, V2, and T2, and we got to figure out what these things are. We don't know the initial volume of the gas, but we know the initial pressure is 0.5 atms. We know that the initial temperature is 325 degrees Kelvin. We know that the final pressure is 1.2 atms. We know that the final volume is 48 liters. We know that the final temperature is 320 degrees Kelvin. So remember, it's P1 V1 over T1 equals P2 V2 over T2. So let's plug in what we know. So 0.5 times our unknown V1 divided by 325 equals 1.2 times 48 divided by 320. We're trying to solve for V1. So that means that I'm going to divide both sides by 0.5. That'll bring it down there. I'll multiply both sides by 325. That'll bring that up there. So V1 is equal to 1.2 times 48 times 325 all over 320 times 0.5. And now, again, calculator time. 1.2 times 48 times 325 divided by parentheses 320 times 0.5. You get 117, exactly on the nose. So that seems like a lot, but it is what it is. 117 liters. That was your initial volume. And that's how we do these.